And a warm welcome also from my side. My name is Christian. I'm a senior consultant at P3 Automotive, an international technology consulting company with a strong footprint in automotive industry. And in fact, we are also working intensively on sodium-ion batteries. That's why I'm delighted to be your moderator for this afternoon's session, and I will guide you through the exciting presentations that we have today. The first topic of today is from Shmuel De-Leon about the sodium-ion battery market 2024, next technology and battery mass production. Stage is yours.
Thank you, Christian, for the introduction, and good morning to everyone. I'm going to talk today about the sodium-ion battery market 2024. It's a very exciting market and very important technology that is going to be a game changer, a new system in the market in the years to follow, and market share will grow as well, and I will explain why. So, sodium ion is different than lithium ion. The reason for that is the sodium ion are moved between the cathode anode, depend if we charge discharge, oppositely to lithium ion on lithium ion system. The technology was heavily researched on the last 7 years, but come into production last year, 2023. One of the most important reasons is no use of lithium, cobalt, nickel, and copper in those cells. Cobalt, of course, is a rare earth material, and other materials cost normally is high due to the high demand on the lithium-ion production business. Industry leaders, CATL, BYD, took decision to make sodium-ion cell. This is not by mistake. They can see the market value for that technology. Hina from China was the first one to build up a gigafactory, and I will talk about them later on. On the Western world, we have only one company, Naton from the US, that decided to start some pilot production. They do that in the Clarios factory in Michigan. We are talking about 20 megawatt of production. It's very small, but it's going to be the first production out of China. What are the advantages? So I mentioned before, no lithium, no nickel, no cobalt. The cost of the cells should be like 60-70% of the LFP cells when we come into mass production. The first cells in the market show today performance of 140 to 160 watt-hour per kilogram, 280 watt-hour per liter. This is definitely not far away from lithium iron phosphate, which are the main competing technology. We have different developer and cell manufacturers, and we can see in the market different pouch, cylindrical, and prismatic sodium-ion cells. It's a 4-volt system, and the nominal voltage is 3.2 to 2.8 volt, which is also very, very similar to lithium iron phosphate. There is a common mistake. People think that sodium ion cannot be discharged in high power. I found cells in China that can be discharged 50C. It's a safe technology, less flammable, not corrosive, and not dendrites. Also, it can be discharged to 0 volt, not like lithium ion that if you do that, you destroy the cell. So theoretically, we can transport the cells in a 0 volt voltage, and then no risk of short circuit, and of course, it's safe transportation. We can use 100% depth of discharge. We can charge up to 2 and 4C charging rate. It's better than majority of the lithium-ion cell in the market, which are only 2C. Some more advantages. The current collectors, both anode and cathode, are aluminum. So not copper in the anode like lithium ion. That means saving cost because aluminum is much cheaper than copper. Operational temperature range is between minus 40 to 80, and that means that it covers even better temperature range than lithium ion, which is minus 20 to 60. Today, first cells in the market can express 4,500 cycles. In the coming future, as much as the technology will be developed, it can reach the best LFP cells of 10,000 and even more. Good shelf life, production done with the same production equipment to make lithium-ion cell. No need to replace the production line. Free from transport regulation. So think about battery pack. You transport lithium-ion battery pack, you pay a lot for transportation because it's regulated. But with sodium ion, we can save money on transportation, and at the end of the day, the customer pay less for the batteries, and this is important. Now, it's non-toxic system except one technology